All right. So again, like I said, we've had polynomial or quadratics that so far we've been able to factor. All right. Well, the quadratic formula is something that when we get to a polynomial or the quadratic that we cannot factor, we use this ugly looking thing. Okay. This is the basic for a quadratic. Notice where the A, the B, and the C are. So when we plug this in, it's the opposite of B, plus or minus the square root of B squared minus 4 times A times C all over 2A. And even on YouTube, there's a quadratic formula song. So you are going to have to understand how to learn it, how to use it. All right. So how this works is you have to set it equal to 0 and then solve using the quadratic formula. So they gave us a scenario. It says consider the equation from problem 4.1, which is actually that's what you're doing next. That model the height of an object launched from the ground. Okay. H equals negative 16t squared plus 64t. You know that from the table, the object reached a maximum height of 15 feet at 2 different times. How can you use the quadratic formula to find the time when the object reaches a certain height? That's what it's asking us to do today. So here's the first. We got a few examples we're going to work on today. All right. So we have to set it up in this ax plus bx plus c, which means we have to take this 15 and we have to move it over to here. How can we do that? How can I move that 15 over? Subtract 15 to both sides. And when I do that, I get negative 16x squared plus 64x minus 15. Now, at this point in time, I am going to identify my A, my B, and my C. So what letter or what number represents A? Negative 16, because it's in front of the x squared. Okay, what number is going to represent B? 64. Because, again, that's the number that's in front of the single variable x. Okay, and then what number is going to represent C? Negative 15. Okay, now that I got all three numbers, we are going to plug those into the quadratic formula. Okay, just like when we factored when we factored out those binomials and things like that, we found our x-intercepts or solutions. That's what the quadratic formula is going to give us. All right, x-intercepts or solutions. So opposite of B. So what's the opposite of B? Well, B is 64. What's the opposite of that? Negative 64, or the negative of it. Plus or minus the square root of, and then we got 64 squared minus 4 times negative 16 times negative 15. Yep, so we're going to definitely need our trusty calculator here because we're talking about some big, big, big numbers. All over 2 times A. All right, so you can see we got a lot of calculating to do here. Well, first of all, let's take care of the calculations underneath the square root sign. Okay, so 64 squared is 4,096. And it's going to be minus, and this is going to be a positive number, right? Because I got 2 negative numbers here. So 4 times negative 16 times negative 15 gives us 960. Okay? 960. And most of the time, they set these up to work out nice. But other times, we may have to round. And then over here, we got negative 32. All right. So 4,096 minus 960 is 3136. All right, and now let's see if we can take. I don't see if the square root of this is even. Oh, it is. If you take the square root of 3,136, it is. Anyone do it? 56. All right, so once we get it down into this stage right here, okay, we get down to this stage right here. Now we break it off into two. That's where this plus minus comes into hand. All right, so you're going to have x equals negative 64 plus 56 over negative 32, and negative 64 minus 56 over negative 32. Remember, when we factored the binomials before, we ended up with sometimes two x-intercepts, right? Or two solutions, all right? So that's how we can get the two solutions here. All right, so negative 64 plus 56 is negative 8. So negative 8 over 32, negative 8 over negative 32 is, yeah, that ends up being 1/4, or 0.25. So that worked out pretty nice. And this one ends up being, if we subtract 56 from negative 64, that's negative 120. And over 32 is 3.75. So our two solutions, or our two intercepts for this particular quadratic, are 3.750 and 1/4 and 0. And these are the two solutions to that quadratic. Again, we use this formula when the expression cannot be factored. All right? Now the ones below can be factored, but I want you to use them practicing the quadratic formula. So at this point in time, if I can find my recorder here, we are going to pause the video, and I want you to work on B and C. All right. So in part B, we have no middle term, right? So when you really think about this as being ax squared plus bx plus c, there's no middle term here. So our a was 25, because that's on the x squared. Our b is 0, and our c is negative 16. So when you plug that into the formula, opposite of b, the 0, there's no opposite of 0, it's just 0. And you get 0 minus 4 times 25 times negative 16. Which you got a minus, and then you end up with a negative number here, which is end up being a plus, right? Because we know we can't take a negative of a square root, right? Square root of a negative. And then this is 2 times 25. Got ahead of myself there. So this becomes 0 plus or minus the square root of 1600 when you multiply those numbers together over 50. Okay? And the square root of 1600 is what? You can tell me. 40. Okay? So this becomes 40. So now we're left with x equals, and this is where that plus or minus now will come into play, right? 0 plus 40 over 50. And then we're going to have 0 minus 40 over 50. That's where that plus or minus is going to come into play once we break down the square root. Okay, because remember, two solutions. Well, you get over here, when you add it, you get 40 over 50, which breaks down into basically just 4/5, right? 10 can go in each of these. And 4/5 is also 0.8 as a decimal, if you do it as a decimal. All right, so there's one solution. And then over here, you're just getting negative 40 over 50, which basically just makes this negative 4/5, or negative 0.8. So those are the two solutions, or x-intercepts, or however else. There's lots of terminology they use for it. Okay? All right, so now we've done two examples. So now I want you to work on a third one where now you got all three. You got an A, a B, and a C. All right? Two examples, hopefully getting just a little bit better at this. All right? So we're going to pause the video again and try to work on C. All right, what did you notice about C that was different from B and A? What'd you come up with? Nothing different? Nothing in terms of solutions? All right, well, let's identify A, B, and C. A is what? 4. B, negative 20. And C is 25. So we plug that into the quadratic formula. opposite of b, so the opposite of negative 20 is 20, plus or minus the square root of negative 20 squared. Remember, we talked about how you put that into the calculator. You can't just type negative 20 squared because you get negative 400. You have to parenthesis it. Okay, it's a negative 20, then square, and then take the square of that. Times 4 times 4 times 25, all over 2 times a. Okay. So we get 400 here, and then this 4 times 25 is 100, times 4 is 400. Oh, this is going to work out easy. This is 0. What's the square root of 0? 0. So when you go to write this, plus or minus over 8, we really can't write that twice, can we? Because 20 plus 0 and 20 minus 0, isn't that the same number? Okay, you could take the time to do that if you want. So if you do that, 20 plus 0, just keeping the rhythm going so you keep it the same. And then you got 20 minus 0 over 8. But watch what happens. I get 20 over 8, which is basically 2.5, right? And over here I get 20 over 8. So I get the same solution. So there is only one solution for this. There's one x-intercept. And usually, what does that mean when there's only one x-intercept? How does that graph look? No, it's not linear, it's quadratic. Okay? When we have two solutions, right? That graph can either look like this or look like that. When there's only one, okay, that means it only hits the x-axis one time. Yeah, the vertex point will be on the x-axis. That's going to be the only point on the x-axis. That's when there only can be one solution. And we don't write the same number twice. So there's only one solution here. Where in A and B, we had two solutions, which means it crossed the x-axis twice. So to answer our summary down below, can every quadratic be factored? No. That's why we have the quadratic formula. The quadratic formula is for a quadratic that cannot be factored. All right? However, the quadratic formula will always work to find your x-intercept or intercepts. I'll put the little parenthesis here because sometimes, and we also sometimes will call them solutions. Okay? So that is the quadratic formula. So for extra practice, because this is a 2-hour block, on the back you have A, B, C, and a D. Want you to take time to practice, and you're going to use the quadratic formula to solve, and then most of those can be factored. You can use the zero product property to check your work and see if you got them right. All right, but make sure you use the quadratic formula to solve.